Okay, we're going to talk a little bit more about position formats or how to describe locations. And I want to start with a couple things that will help your understanding of interpreting topo maps. When we were doing watershed delineation, I kept mentioning that you need to delineate around a stream corridor by marking the high points, this point here, this point here, and that any snow that melted off this whole area here would drain down into Pilcher Creek, for example, in this map. But you might wonder, well, how do I know that? How can I tell that from this map? So I want to just make a couple things clear and link them between the watersheds class and the field skills class. So to understand which way water flows or snow melts or snowmelt drains, you have to understand where the high points are and where the low points are in the topography. And to help visualize that, these lines, all of these brown lines, which are called contour lines, are marked with elevations. Every fifth line is called an index line, and the index lines actually have the elevation written on them. So here's 6,400. Here's one up here that says 6,600. Here's 7,000. So what this means is that everywhere along this brown line, this dark brown line, at every single point along this dark brown line is the same elevation. And in this case, it's 7,000 feet above sea level. Every single place along this dark brown index contour is 6,600 feet. And so I know that if this is 7,000 feet here and everywhere along this line is 6,600, that this is downhill. And so if I know that if I'm here, water is going to drain down the slope. And the specific direction that it's going to drain might also help you with both interpreting topo maps and also figuring out watershed delineation. So the way that it's going to drain is perpendicular to these contour lines. So if this line here, this dark brown index line, is running directly across the hill slope, then when water drains or moves or flows, it's going to flow perpendicularly to these lines. So you can always draw or visualize a pathway at a 90-degree angle to these contours, and that's the way that water is going to move. The other term that's important is called aspect. And so aspect is essentially the direction, the compass direction that any given hillside or topographic feature is pointing. So if I'm standing here, and this is a little knob, a knoll, or a peak, I'm standing here, and I point my toes downhill, or I point my toes in the direction that water is going to flow as it rolls down the hillside. So I'm also doing the same thing. I'm pointing my toes at a 90-degree angle to these contour lines, and that means I'm pointing directly down the hill. Then to determine what aspect that is, you say, well, what compass direction is that? And so if I'm going to draw a line that points in that direction, what compass direction is that? What cardinal direction is that line pointing from here to here? Well, I would say that that's southwest. On the other hand, let's find a different aspect. So this hillside here, which is above Bees Cove Creek, and this is all up in the Rattlesnake. So this whole hillside has roughly the same aspect, and it's the same direction that water would flow if it were running down this hill. And so first of all, I say, okay, well, what direction is downhill? Well, this says 6,800, this says 6,000. So I know that this is in the downhill direction. And if I visualize a line that's perpendicular to these, that's the direction that water would flow. And that's also the direction that I use to determine what aspect this hillside has. And so if I'll just draw it for you. Let's just do a line. If I draw a line perpendicular, roughly perpendicular to these contour lines here, it might look something like that, right? Okay, and so that being downhill, that's an eastern aspect. Really, I feel like to be honest, I feel like it's more like that. I don't know. This whole hillside feels like it's drains more like that. So it's more southeast. Okay, so that would be a southeast aspect for a hillside. Okay, so we have aspect, and we also have understanding, what's downhill and what's uphill. And also remember that these contour lines, when they form a loop like that, a closed loop, that means you're on a hill. That means you're at the top of a hill. The smallest circle on the interior of all of these, or the smallest loop in the interior of all of these, that's the high point. That's the peak or the knob or the knoll. And the space in between this knob and this knob, this space right here, is called a saddle. And again, I think I mentioned that to me, it reminds me of a figure 8 shape around a saddle, right? So you could draw the top half of the figure 8, then it pinches in here, and then it comes back around, right? So there's my figure 8. So the pinched in point on the figure 8, that's a saddle. I see another saddle here. There's a saddle over here. So anywhere that you can identify between 2 points, between 2 knobs or knolls, the low point between them is called the saddle. Okay, so what we are going to do now is look at a different type of position format. So let's just remind ourselves, if we were in the township range and section system, again, we'd have to look at a large scale hard copy topo map to know what our township and range is. But if we're looking at Pilcher Creek and we want to know what the description of this point is in that township range and section system, I would say that it's in the northeast quarter of the northeast quarter of section 8, just as a reminder. Okay, we're going to look at a brand new system of identifying a location. So that's called a position format. So the township range and section system was one type of position format. And this next one that you're going to learn is called the UTM system, or the Universal Transverse Mercator System. So we're going to use as an example a particular marker that I made in my CalTopo suite of maps, and this is for a peregrine falcon nest that I've been monitoring for a bunch of years up in the Rattlesnake. And I go up there over and over again and check on them and see if they're nesting and if they've raised young and that sort of thing. So if I click on that marker in CalTopo, that red marker, I'm going to get this screen. And one thing you'll notice right up at the top is that it gives a whole bunch of numbers. The top set of numbers is obviously latitude and longitude. And the format that it's in, the format that the latitude and longitude numbers are in, is called decimal degrees. So we just have a single degree, 46, followed by a decimal here indicating what you might consider to be the minutes and seconds. So this is some fraction of 46 degrees. And then the longitude is negative 113 point blah, blah. Why negative? Well, I'll just tell you one thing. If you don't put the negative there and you just type in 113, you're going to be sent to Korea. So negative 113 indicates that we're west of the prime meridian. So that we're, as you go from the prime meridian through Greenwich, England, west to the international date line, that's all the negative side. And then if you go east of the prime meridian, then you don't need to put a negative. Those are all the positive longitudes. So be careful, because if you don't type in negative, you will quickly leave Montana. Why don't I normally like using latitude and longitude? It's because from the field point of doing, or the standpoint of doing field work, the latitude and longitude system was designed for mariners. It was really designed for ocean exploration. And it's a fabulous tool if you have miles and miles of just horizon out there in front of you. It's not very useful on a human walking scale. So on the scale of a human being walking through the mountains or even walking across the plains, it's not very useful. There's terrain in the way as you start walking across the earth. And if I tell you to go walk 100 meters, you roughly understand what I'm talking about. If I tell you instead, go walk 2 degrees, 4 minutes and 13 seconds, like what distance is that? So it's not a useful system for walking. So we're going to instead learn the UTM system, which is very valuable for a human scale of walking. And that's what this second set of numbers is. So I want to explain, it looks kind of daunting, but it's not at all. It's a very simple system, and you're going to discover that it's way better and way more user-friendly than the old latitude and longitude system. So let's break it down just briefly, and I'll go onto a map and show you where you get this stuff. But briefly, there's kind of 3 components here. There's a number and a letter, okay? That's your zone. It's called your zone. And then this is your latitude band, essentially. And then you've got a whole bunch of numbers followed by the letter E, and then a whole bunch more numbers followed by the letter N. So this is what's called the easting value. This whole thing is the easting value, and this whole thing is the northing value. So you can see that it's pretty similar to latitude and longitude in the sense that this number is kind of similar to the idea of latitude. It's how far north of the equator you are. And this number here is similar to a longitude in that it shows you where you are on an east-west scale. Okay? But you notice that the easting always comes first. So unlike here in this system where your latitude, your north-south scale goes first, here the east-west number comes first, and then your northing comes after that. So how far away you are from the equator vertically. Okay, so if you further dig into that marker for my peregrine falcon nest, here's where you get so much information. It's absurd, but it's also awesome. The very first thing they give you, and I think that's only reasonable because it's the best system, is the Universal Transverse Mercator System, or the UTM. And again, here's your 3 basic things. Number followed by a letter, a bunch of numbers east, and a bunch of numbers north. That's the basic system for a UTM. The lovely thing about what CalTopo does is they give you this option of how to read it. So in other words, if you have to read this over a radio or describe it to somebody over the phone, this is how you would say all that gobbledygook. So you would say, I'm at zone 12T 0277578 east by 5204466 north. That's how you would read it or verbalize it. Forget this U.S. National Grid. That's you can see some of the numbers are the same, but this is more for military use, sometimes search and rescue use. The last 3 are the latitude and longitude, and you'll notice that they put them last because they're not very useful for us hikers. So the first one being decimal degrees, so it's the latitude and the longitude followed by a decimal, as opposed to degrees with decimal minutes, so where your minutes have a decimal, or degrees, minutes, and seconds. Notice that every single one of these defines the exact same location, just in a slightly different system. And I also want to just point out this whole negative thing here. Notice that there's no word negative over here. There's no by negative 113 degrees. It's 113.9233 degrees west, meaning it's west of that prime meridian, as opposed to east. Okay, so let's understand a little bit more about this old UTM system. Our U.S. military designed this system to identify targets around the world or locations around the world, and they've mapped the entire world from the north to the south poles. And the very first thing they did was they cut the whole planet up into basically orange slices, and there's 60 of them. So starting with the international date line, each of these slices is numbered, going all the way around, and there's 60 of them, okay? So the slices that make up the continental United States go from about 10 to about 19. So these slices here, right, cover, the Puget Sound and the whole West Coast over to Florida, the eastern seaboard, clear up into the Maine. So these are the slices that you're most frequently going to be working with if you're anywhere in the United States. Okay, so each of those slices, then you can the very first thing you're going to tell somebody is which slice are you in, and then within those slices you can see, right, if you say you're in slice 16, I mean, you could be down in Guatemala or clear up here on Hudson Bay. So where in the slice are you? And that's where the latitude bands come in. So from the equator down here, moving north, we cut this whole northern hemisphere up into bands, and we did the same thing for the southern hemisphere. And this is roughly what it looks like if you take a single orange slice, right? The top of the orange slice is pinched off at the North Pole. The bottom of the orange slice is pinched off at the South Pole. And the widest section is right there through the equator. So these letters over here represent all the what are called the latitude bands. And really, the cool thing for you to know is that as soon as you hit the equator, the letters turn to, that's where the letter N and everything following that begins. So N is for northern hemisphere. So the letters C, D, E, F, G, and on are in the southern hemisphere. As soon as you hit N, you're in the northern hemisphere. So it makes sense for us that because we're, I don't know, roughly halfway between the equator and the North Pole, we're somewhere in the S's and the T's. We're usually in Montana, somewhere in this region right in here. Okay. That's, I think, all I want to say about that. When you get down to a smaller and smaller, more zoomed in version of the UTM system, you're going to see that it looks something like this. And most hard copy maps, like, I don't know when the last time you bought a hard copy 7.5 minute map was, but the last time you did, you'll notice that primarily around the outside there are latitude and longitude numbers, which are utterly pointless. But there's also these little blue numbers, at least on this map, they're blue. Most hard copy topo maps, though, don't have the grid lines connecting the easting here and the same easting here. They aren't connected. So in a pinch, you can always draw those grid lines in yourself to connect them. The beautiful Cairn cartographic maps you took on the trek, those maps did have a UTM grid printed on them over top of the lat long grid. So let's make sure you understand what these numbers are for, and then we'll figure out how to identify a location with these numbers. So these numbers here, these are the eastings, okay? And you notice that they're getting bigger as I head east. So this, how do you read this? Like, how would you describe this number? This number is 274 kilometers. And why do I say that? Because this whole number here is the number of meters within my slice, basically east of a particular midline of my slice. It's kind of an arbitrary set of numbers. It's not east of the west edge of my slice. So let's just figure out how to read this, and then we'll talk about what it means. So this is 274 kilometers, or 274,000 meters. This over here is 275,000, 276,000. So how many meters is it from here to here? It's 1,000 meters, or a kilometer, okay? And if you look going up in the northern direction, you'll see it's the exact same thing. So this is 5,195,000 meters, aka 5,195 kilometers, 5,196 kilometers, 5,197 kilometers. So these are a kilometer on a side. Remember, in the township range and section system, the grid squares were a mile on a side. So these are a kilometer on a side. Okay, so as I'm going from here to here, I'm moving 1,000 meters. As I'm going from here to here, I'm moving 1,000 meters. So if I want to identify the location of the very top of Mount Jumbo here in the UTM system, I always start with the easting, okay? Once I know my zone and my latitude band. And by the way, down here, you'll notice it tells you what your zone is, zone and your latitude band. So we're in zone 12 in Missoula, and this is our latitude band, T. And just as a reminder, does that surprise you? So we're in zone 12 here, so we're right on this border. We're right on this border. We just hopped over this border right here. We're in zone 12. And, oops, we're also in latitude band T. So we're up in here, which is what we thought, because we're a little more than halfway between the equator and the North Pole. Oh my gosh. Okay. So again, if we look here, our very first two things we're going to write down are 12T. And then we're going to write our easting. And the saying with the UTM system is you always read right up. In other words, you read the easting first, so you read to the right first, and then you read up, the northing, second. So read right up means you read to the right first, which is your easting number, and then you read up, read right up. That's your northing, okay? So to get this, I have to start with the easting here, okay? Because notice my easting here is 274 kilometers, and my next easting is 275 kilometers. And this is, whatever, 3/4 of the way between the two. So normally what I do is if I'm trying to write something down, I will write down, and it's important that you give this leading 0 here, because there's, notice how many digits there are? There's 7 digits here, and there's 7 digits here, and you need to write down a specific number for every one of those. So if the leading digit here is 0, you enter 0. So it would be 0, 2, 7, 4, right? And then some number of meters. So you are trying to fill in those last 3. You're trying to figure out how many meters am I between here and here. If I was right on this line, it might be 999 meters, right? As soon as I hit the next line, then I've gone 1,000 meters. So I like to eyeball it first and say, well, it's about, 3/4 of the way. So 750 meters, maybe 800. I don't know. You decide. So I know that my first 4 numbers are going to be 0, 2, 7, 4. And if I was going to give a really rough estimate, I might say that this is 0, 2, 7, 4, 7, 5, 0, because it's like 3/4 of the way between here and here. We can get more specific, but I'm just showing you how to eyeball it at first. Okay, so I've done my easting now. It's 0, 2, 7, 4, 7, 5, 0. Now I do my northing, right? I read right, and then I read up. And notice that, man, Mount Jumbo is nearly on one of these UTM grid lines. So let's try to remember where we're going to start. We're going to start here. My first 4 digits are going to be 5195 because I'm somewhere between 5195 and 5196. So I'm somewhere between here and here. So my first 4 digits are 5195, and then I've got to come up with what my next 3 digits are. So 5195, if it was in here, it would be 5195, 500, right? But I'm almost up there. So what do you think? 5195, 950? Am I 950 meters north of this baseline? I don't know, 950? That's what I'm going for. Okay, so that would be my easting and my northing. Okay, they're funny words, right? So my easting is 0274750, and my northing is 5195950. That's my guess. Okay, does that make sense? So you have to figure out which grid you're going to start with. And so you always start in the southwest corner of the grid. So if I'm looking for this point here, I'm going to start here and I'm going to move to the right until I get to my objective, and then I'm going to move north. Okay, so I'm going to read my easting and then I'm going to read my northing. So if I start in this corner, I know that my first 3 or 4 numbers are going to be, for my easting, are going to be these. And for my northing are going to be these. Okay, so always find your objective first. If this is my objective, I'm going to start down here. I'm going to read right, and then I'm going to read north. Okay, what if my objective is here and I don't have a southwest corner because my southwest corner is somewhere over there? I can still read my northing, but I might have to start here with my easting and work backwards. So how far back is that objective? So I'm going to have to say, what will my first 4 digits be of this objective, or sorry, this one here? What will my first 4 digits be? Well, they're going to be 0, 2, 7, 3, right? It's not even written on the map, but it's somewhere over here, but you can just tell because we're working backwards, 275, 274, so this is going to be 273, okay? And then I can just subtract from here because I'm starting at 1,000 and I'm working backwards to that. And honestly, that looks like it's, I don't know, maybe halfway back. Maybe this is 600 meters, right? So from here to here is 600 and this is 400. I don't know, you decide. Okay, so if you don't have a whole grid, that's okay. Work backwards from what you've got. Like down here, for this trail junction right here, if you had to figure out the UTM for that, I'm going to have to work backwards from my northing down, and I'm going to have to work backwards from my easting across because I don't have either a top or a bottom to work from. I have no southwestern corner to work from, so I'm going to have to do some subtracting. But remember, it's simple because you're always subtracting from 1,000, right? So my easting here is going to be 0,273, something, something, something. And my northing, what will my northing be? What are the first 4 digits of my northing for this point right here? It's going to be 5194. And then you have to come up with the last 3 digits. Okay, how darn simple is that? Super simple. So here's what it all looks like. Okay, your zone, your hemisphere, your easting, almost always starting with a leading 0. And oftentimes people will write the little letter M, meaning meters, but I don't. I don't think there's a need to. It's self-evident. There are no other types of units you're going to use. It's only meters. East, and then your digits, and then north. Okay. There we go. Okay, to be very detailed about those final 3 digits, the most important thing is that you use your scale that you've got on your map. So you can see that there's a couple scales down here at the bottom, and the top scale is kilometers and the bottom scale is miles. So since the UTM system uses kilometers, you're going to use the top scale. And what I would do is notice that it's broken up into, and you're going to have to figure out what those are. So if this is 0 and this is 1 kilometer, what's each one of these? Any ideas? 100 meters. So here's 100, 200, 300, 400, 500 meters. And then they didn't break up the second 500 meters. But you can use this scale here. And what I normally do is if I'm working out in the field with a paper map, I just get a scrap edge of a different map or the scrap edge of a piece of paper in my field notebook, and I just mark these down. I literally draw this on the edge of a piece of paper and mark off 1, 2, 3, knowing that I'm counting in hundreds of meters, 4, 5, and then I keep going. And when I'm done marking these 5 off, I move my paper over and mark these 5 off so that I've got an entire kilometer. And that way, if you're going to figure out, a more exact position for this, then I just lay that piece of paper down that's got these markings on it. I just lay it down and I start counting from here, and I just can count exactly over to my objective. And I can eyeball within this 100 meters, you know. So if something here would be about 50 meters, something, further over here would be in the, 475. So you can get more specific if you have more finer marks for your kilometer scale. Okay.